Charged particle of mass 5 into 10 raised to the power minus 5 kilogram is held stationary in space by placing it in an electric field of strength 10 raised to the power 7 Newton per Coulomb, directed vertically downwards. The charge on the particle is option A minus 20 into 10 raised to the power minus 5 microcoulomb, option B minus 5 into 10 raised to the power minus 5 microcoulomb, option C 5 into 10 raised to the power minus 5 microcoulomb. Option D 20 into 10 raised to the power minus 5 microcoulomb. Correct answer option B minus 5 into 10 raised to the power minus 5 microcoulomb. Two electric charges 12 microcoulomb and minus 6 microcoulomb are placed 20 centimeter apart in air. There is a point P on the line joining these charges and outside the region between them, at which the electric potential is 0. The distance of P from the minus 6 microcoulomb charge is option A 0.10 meter, option B 0.15 meter, option C 0.20 meter, option D 0.25 meter. Correct answer option C 0.20 meter. To E1 I cap plus E2 J cap plus E3 K cap is R is equal to AI cap plus BJ cap. The work done is option A Q into A E1 plus B E2, option B Q into under root A E1 whole square plus B E2 whole square, option C Q into E1 plus E2 into root A square plus B square, option D Q into under root E1 square plus E2 square into A plus B. Correct answer option A Q into AE1 plus BE2. Two charges of 4 microcoulomb each are placed at the corners A and B of an equilateral triangle ABC of side length 0.2 meter in air. The electric potential at C is, take 1 upon 4 pi epsilon naught as 9 into 10 raised to the power 9 Newton meter square per Coulomb square. Option A 9 into 10 raised to the power 4 volt. Option B 18 into 10 raised to the power 4 volt. Option C 36 into 10 raised to the power 4 volt. Option D 36 into 10 raised to the power 4 volt. Correct answer option C 36 into 10 raised to the power 4 volt. An electron of charge E Coulomb passes through a potential difference of V volts. Its energy in joules will be option A V upon E, option B E into V, option C E upon V, option D V. Correct answer option B E into V. Two capacitors A and B are connected in series with a battery as shown in the figure. When the switch S is closed and the two capacitors get charged fully, then option A, the potential difference across the plates of A is 4 volt and across the plates of B is 6 volt. Option B, the potential difference across the plates of A is 6 volt and across the plates of B is 4 volt. Option C, the ratio of electrical energies stored in A and B is 2:3. Correct answer option B, the potential difference across the plates of A is 6 volt and across the plates of B is 4 volt. A hollow metal sphere of radius 5 centimeter is charged such that the potential on its surface is 10 volts. The electric field at the center of the sphere will be option A 50 volts per meter, option B 10 volts per meter, option C 5 volts per meter, option D 0. Correct answer option D 0. In a uniform electric field, a charge of 3 Coulomb experiences a force of 3000 Newton. The potential difference between 2 points 1 centimeter apart along the electric lines of force will be option A 10 volt, option B 30 volt, option C 100 volt, option D 300 volt. Correct answer option A 10 volt. An electron of mass m and charge E is accelerated from rest through a potential difference V in vacuum. The final speed of the electron will be option A, V into root E by m, option B, root EV by m, option C, whole root 2EV by m, option D, 2EV by m. Correct answer, option C, whole root 2EV by m. In the circuit shown in the figure, each capacitor has a capacity of 3 microfarad. The equivalent capacity between A and B is option A 3 by 4 microfarad, option B 3 microfarad, option C 6 microfarad, option D 5 microfarad. Correct answer, option D 5 microfarad. A cube of side B has charge Q at each of its vertices. The electric field at the center of the cube will be option A 32Q upon B square, option B 0, option C Q upon B square, option D Q upon 2B square. Correct answer, option B 0. In a charged capacitor, the energy is stored in option A positive charges, option B both in positive and negative charges, option C the electric field between the plates, option D the edges of the capacitor plates. Correct answer, option C the electric field between the plates. If a proton is brought towards an electron from infinity, then potential energy of the system will option A decrease, option B increase, option C first increase and then decrease, option D remain unchanged. Correct answer, option A decrease. Sphere of 0.2 meter diameter bears 1 microcoulomb charge on it. The maximum electric intensity at a point due to the sphere will be option A 9 into 10 raised to the power 9 Newton per Coulomb, option B 9 into 10 raised to the power minus 9 Newton per Coulomb, option C 9 into 10 raised to the power 5 Newton per Coulomb, option D 9 into 10 raised to the power minus 5 Newton per Coulomb. Correct answer, option C 9 into 10 raised to the power 5 Newton per Coulomb. 3 positive charges of equal value Q are placed at the vertices of an equilateral triangle. The resulting lines of force should be sketched as in option A, option B, option C. Correct answer, option C. Consider the situation shown in the figure. The capacitor A has a charge Q on it, whereas B is uncharged. The charge appearing on the capacitor B a long time after the switch is closed is option A 0, option B Q by 2, option C Q, option D 2Q. Correct answer, option A 0. A uniform electric field pointing in the positive x direction exists in a region. Let A be the origin, B be the point on the x-axis at x is equal to +1 centimeter, and C be the point on the y-axis at y is equal to +1 centimeter. Then the potentials at the points A, B, and C satisfy option A, VA less than VB, option B, VA greater than VB, option C, VA less than VC, option D, VA greater than VC. Correct answer, option B, VA greater than VB. Two equal negative charges minus Q are fixed at the point 0A and 0 minus A on the y-axis. A positive charge Q is released from rest at the point 2A0 on the x-axis. The charge Q will, option A, execute simple harmonic motion about the origin, option B, execute oscillatory but not simple harmonic motion, option C, move to the origin and remain at rest, option D, move to infinity. Correct answer, option B, execute oscillatory but not simple harmonic motion. A ball of mass 1 gram and charge 10 raised to the power minus 8 Coulomb moves from a point A whose potential is 600 volt to a point B whose potential is 0. Velocity of the ball at the point B is 20 centimeter per second. The velocity of the ball at the point A is option A 2.8 centimeter per second, option B 2.8 meter second per second, option C 16.7 centimeter per second, option D 16.7 meter per second. Correct answer option A 2.8 centimeter per second. In a parallel plate capacitor of capacitance C, a metal sheet is inserted between the plates parallel to them. The thickness of the sheet is half of the separation between the plates. The capacitance now becomes option A C by 2, option B C by 4, option C 4C, option D 2C. Correct answer option D 2C. While a capacitor remains connected to a battery, a dielectric slab is slipped between the plates. Option A, the electric field between the plates increases. Option B, the energy stored in the capacitor decreases. Option C, the potential difference between the plates is changed. Option D, charges flow from the battery to the capacitor. Correct answer, option D, charges flow from the battery to the capacitor. A body of capacity 4 microfarad is charged to 80 volt and another body of capacity 6 microfarad is charged to 30 volt. When they are connected, the energy lost by 4 microfarad capacitor is option A 7.8 millijoule, option B 4.6 millijoule, option C 3.2 millijoule, option D 2.5 millijoule. Correct answer option A 7.8 millijoule. There is a uniform electric field of strength 10 raised to the power 3 volt per meter along y-axis. A body of mass 1 gram and charge 10 raised to the power minus 6 coulomb is projected into the field from origin along the positive x-axis with a velocity of 10 raised to 10 meter per second. Its speed in meter per second after 10 seconds is neglect gravitation. Option A 10, option B 5 root 2, option C 10 root 2, option D 20. Correct answer option C 10 root 2. A 20 farad capacitor is charged to 5 volt and isolated. It is then connected in parallel with an uncharged 30 farad capacitor. The decrease in the energy of the system will be option A 25 joule, option B 200 joule, option C 125 joule, option D 150 joule. Correct answer option D 150 joule. If the charge on a body is increased by 2 coulomb, the energy stored in it increases by 21%. The original charge on the body in coulombs is option A 10, option B 20, option C 30, option D 40. Correct answer option B 20. Two spheres A and B of radii small a and small b respectively are at same electric potential. The ratio of the surface charge densities of A and B is option A upon B, option B upon A, option C A square upon B square, option D B square upon A square. Correct answer option B upon A. 2-point charges placed at a distance r in air exert a force F on each other. The value of distance capital R at which they experience the same force when placed in a medium of dielectric constant K is option A R into K, option B R upon K, option C R upon root K, option D R root K. Correct answer option C R upon root. The electric potential at any point x, y, z in meters is given by V is equal to 4x square volts. The electric field at the point 1 meter, 0, 2 meter in volts per meter is option A 8 along negative x-axis direction, option B 8 along positive x-axis direction, option C 16 along negative x-axis direction, option D 16 along positive z-axis direction. Correct answer, option A, 8 along negative x-axis direction. Electric field intensity at a point in between two parallel sheets with like charges of same surface charge densities sigma is option A, sigma upon 2 epsilon naught, option B, sigma upon epsilon naught, option C, 0, option D, 2 sigma upon epsilon naught. Correct answer, option C, 0. Electric potential at an equatorial point of a small dipole with dipole moment P, r distance from the dipole is option A 0, option B P upon 4 pi epsilon naught r square, option C P upon 4 pi epsilon naught r cube, option D 2P upon 4 pi epsilon naught r cube. Correct answer, option A 0.